In part A of this question, we are given that curve C is having this equation over here, and we are supposed to sketch curve C. And in order for us to sketch curve C, it would have been better if we were to try to look at this equation and think of whether it is possible for this to follow some slightly more standard equation that we actually know about the curve. And if you have that gut feel that you acquire through practice, then this probably will remind you of maybe one of the conics. So we're going to test this out, okay? We're going to try to see whether we can convert this, manipulate this equation so that it can look like one of the conics. So I am going to first, let's say, factorize out 4 from here. We're going to try to do a bit of completing square, which will be getting us an x squared minus 6x plus this. I'm going to just leave it as it is. This is equal to 0. So let's try to complete the square for this, which will be x minus 3 squared minus 3 squared over here plus 9y squared. This is equal to 0. So we will have a 4x minus 3 squared. 4 times 9, 36. Negative 36, if I were to shift it over to the other side of the equal sign, it is going to be positive 36. So if it is plus 9y squared, this is equal to positive 36. And dividing throughout by 36, it will be giving me an x minus 3 squared over 9, which I'm going to write it as 3 squared, plus y squared over 4, which I'm going to write it as 2 squared. So now we are seeing a standard equation. The standard equation is an ellipse. An ellipse with the center at 3, 0, and the horizontal radius is 3, the vertical radius is 2. Now we are ready to sketch this curve C by basing it on the equation of an ellipse. Okay, so like what we have just talked about, if I were to try to sketch this graph, it will have a center at 3, 0. So let's say it is here. Okay, so this is at 3, 0. The horizontal radius is 3. So it is going to be passing through the origin. And since the question requires us to code the coordinates of the points where the curve meets the axis, I'm going to use 0, 0 here instead of just writing the alphabet O. And plus 3, it is going to be passing through this point here. So 6, 0. The vertical radius is 2, so vertically up, we will have maybe this point here, okay, which will be x coordinate is 3, y coordinate is going to be 2, and vertically down, maybe somewhere here, this will be 3 and negative 2. Let me connect these few points together to form the ellipse. So we have something that is like this. Okay, so from here, connected to here, and this part connecting back to here. Okay, I think this is quite okay as a curve that represents the ellipse. Let me label this curve. So I can label it using this equation of curve C that was originally given to us. So 4x squared minus 24x plus 9y squared, this is equal to 0. And in part B, we are supposed to describe a sequence of transformations that transform the graph of C onto the graph of x squared over 9 plus alpha y minus 1 squared over 4 is equal to 1, where alpha is a positive constant. So, okay, let me just think about the possible algebraic manipulation that I need to do, or algebraic changes that I need to do to get from this curve to the one that is stated by the question. Okay, I'm going to use this. Okay, I think this is way more similar to the one that is given to us by the question. In fact, I'm going to see this here as 9, and I'm going to see this here as 4. So starting from x minus 3 squared over 9 plus y squared over 4 is equal to 1. To get to what we have there, right, I am going to try to replace this x. Okay, I'm going to try to replace this x here by x plus 3. So this minus 3 squared over 9 plus y squared over 4. This is equal to 1. So this will now be x squared over 9, which is the same as what the question is asking me for this part. And this plus y squared over 4 is equal to 1. We need to do some more work for this, okay? So the next thing that I'm going to do is I'm going to replace this y here. So I will replace this y here by y minus 1. So we will have this over 4 is equal to 1. And I'll replace this y again. So x squared over 9 plus replacing this y this time by alpha y minus 1 squared over 4. This is equal to 1. Okay, now we are ready to describe the transformation. So the first step is replacing x by x plus 3. So step 1. It is going to be, since we are replacing this x here by x plus 3, it is going to be a translation of 3 units in the negative x direction. So let me write that down. Translate by 3 units in the negative x direction. Negative x direction. Step 2, I am replacing this y here by y minus 1. So the second transformation that I'm going to be doing will be, since we replace this y by y minus 1, it's going to be a translation of 1 unit in the positive y direction. So translate by 1 unit in the positive y direction. Okay, then we will be replacing finally y by alpha y. And it is important for us to acknowledge the fact that alpha is a positive constant, or else there will be a reflection that is going to be taking place. So it is just replacing y by positive alpha y. So this last step here, step 3, it is going to be a scaling. And we're going to scale by a factor of 1 over alpha parallel to the y-axis. Okay, so this will be the 3 transformations that I need to get this for part B of the question. Let's look at part C. Part C, state the value of alpha for which the resulting curve that we have obtained from part B, which is this, is going to become a circle. Okay, let's look at this equation here, okay? So in order for this to become a circle, we first need to make sure that the coefficient of y is going to be 1. Okay, so let's take out the coefficient of y. So we have an x squared over 9 plus, taking out the coefficient of y, we have a alpha squared. Then y minus 1 over alpha. So we have this square over 4 is equal to 1. And the next thing that we will need to do is to make sure that the coefficient of this entire thing is 1. So we are going to bring this down, okay? So if I were to be bringing this down, then it is going to be 4 over alpha. Let me just write it down here. 4 over alpha, so that I'm bringing this down so that the coefficient here is just 1. And one last thing that I will try to consider in order for this to become a circle is this number and this number, they must be the same. Okay, if they were to be the same, then I can multiply this number across to the other side, which is going to represent radius square. So it will be x squared over 1 plus y minus 1 over alpha square over 1 is equal to this number, which I know what it is. It is going to be number 9. So I need this to be exactly the same as this. So we are going to let 4 over alpha square be equal to 9, which means that alpha square is going to be equal to 4 over 9. So alpha is going to be equal to 2 over 3. And are we going to consider negative 2 over 3? We are not going to, because again, the question mentioned to us that alpha must be positive. So let me write down the reason here, because alpha must be a positive number.